Now let's cover the humoral immune response. And recall that the humoral response involves B lymphocytes when they encounter their very specific target antigen, that foreign antigen that's not part of self proteins. So the humoral immune response is provoked when the B cell binds with the antigen. When it does so, it creates antibodies specific for that antigen and mark that antigen for destruction. So here's a foreign antigen specifically binding to these receptors on this B cell. These other B cells have receptors, but those receptors are not for this particular antigen. We need this specific binding of the antigen with the receptor on the B cell. When the antigen binds to the receptor, the B cell becomes activated, and those surface receptors cross-link to one another, and that causes endocytosis. You don't see it here, but the receptors are taken into the cell, which activates the B cell. And activation will lead to proliferation and differentiation, which we see here. This one cell is dividing, they continue to divide, and we get this clone of B cells that produce antibodies. Here are the antibodies that it's secreting, which will go ahead and mark all of these antigens for destruction. So these B cells that are clones that produce the antibodies are effector because they're activated B cells, but we call these effector B cells plasma cells. Now, not all the clones are plasma cells. Some of them are put aside for memory, and we call these memory B cells, which can respond much quicker the next time we're infected by this specific antigen. So, like we just saw, most clone cells become plasma cells, which are the effector cells. They secrete specific antibodies, 2,000 a second, for 4 or 5 days, then they die. Antibodies circulate in the lymph and the blood. They bind to free antigens, marking them for destruction. Clone cells that don't become plasma cells, so the ones that aren't the effector cells producing antibodies, become memory cells, so that upon future exposures, the response is more immediate. So here's a secondary response. There's our memory B cells, and it becomes in contact with that antigen, same antigen as the first contact. Now we have that cross-linking, same thing as the primary response, but these plasma cells are produced much quicker, at a much higher rate, and we're going to see how much faster on the next slide. And of course, we're always going to put a few aside for memory. So you can see upon first exposure to an antigen, it takes a few days before plasma cells develop and begin to secrete antibodies. And we can see there's really no significant level of antibodies until about a week after the infection. So during that week, good chance that you will be sick from the infection. And then eventually they'll die off. Now, if we're exposed to that same antigen a second time, remember we have memory B cells now from this first exposure. Upon second exposure, well, what happens is it doesn't take 7 days, which would be way over here. At 35, we can see within a few days we're already mounting this huge attack of antibodies, and way more antibodies than we did during the first exposure. So we're better able to respond to the infection and deal with the infection upon subsequent exposures. Now, if we're introduced at the same time to a new antigen, antigen B, we can see, well, look how much longer it takes for that primary response versus the secondary response. So we just looked at active humoral immunity, and active because the B cells are encountering the antigens and they're producing antibodies. That's what makes it active. This can happen two ways, naturally or artificially. Naturally means just get infected. Whenever we're infected with an antigen, this will happen naturally. And this is typically the best way to acquire immunity, is through naturally acquired form of humoral immunity. So that's just actual bacteria or actual viruses entering our system. Now, we could obtain active humoral immunity artificially through vaccines of dead or attenuated, this means weakened, pathogens. So vaccines are a way to give the person the antigen, but not through a natural means, through an injection, typically. So the same thing is going to occur. Plasma cells will be created once the B cells are activated and produce antibodies, which will also have memory B cells, so we can acquire immunity the same way. Sometimes, though, not as long as the natural route. But you see the benefits of vaccine, wiping out smallpox and polio. It lessens the illness in many diseases, like these ones listed here. And they've substantially reduced the prevalence of these other diseases, like hepatitis B, tetanus, the flu, pneumonia, etc. Now, humoral immunity is passive when we don't make our own antibodies. This is when antibodies are being introduced to us, so our B cells do not have to do the work. The B cells are not activated, they don't become plasma cells, they don't produce and secrete antibodies. Antibodies are just simply introduced to us. But there's two types of passive immunity. One is natural and one is artificial. So naturally acquired passive humoral immunity is when antibodies are just passed from the mother to the infant, or fetus, I should say, through the placenta, or to the infant through milk. Artificially acquired passive humoral immunity is when antibodies are simply injected into a person. Typically, this is not ideal. Typically, this causes an immune reaction. However, usually this artificially acquired route is taken in emergency situations like snake venom, rabies, tetanus, hepatitis A, for example. So this is not a route you would really want to take unless you had to, because you'd take an allergic reaction over something fatal, of course. So be sure to organize these routes for yourself. Humoral immunity could be active or passive. Active could be naturally or artificial. Passive could be natural or artificial.